Hi! Now let us learn about thermal expansion. Okay. First, I want to talk about linear expansion. Suppose I have a rod with initial length L naught at some initial temperature T naught. Okay. I have a rod. Okay, with at this length L naught, and initial temperature is only 20 degrees Celsius. Now I heat up the rod. What happened to the rod is it will expand when heated up. Okay, so I heat it up until the final temperature of 100 degrees Celsius. So 100 degrees Celsius is the final temperature. Okay, initial temperature is cold, final temperature is hot. So I heat it up to 100. So this rod will expand. So the expansion is delta L. Okay, the expansion is delta L. This is the initial temperature L naught, and L is the final temperature. No, L is the final length. L naught is the initial length. L is the final length. I just write it as I can write it as a L final. Okay, so delta L is the expansion. Okay, and LF is the final length. L naught is the initial length. So for this one, expansion is different from thermal conduction, heat conduction. As you remember, for heat conduction, if you remember, heat conduction, heat always flow from hot to cold. Okay, heat always flow from hot to cold. So the initial is hot temperature, final is cold temperature. So we want to find the change in temperature, we use the final minus initial, which is the cold minus the hot. Cold minus the hot. But for thermal expansion, we are heating the rod from cold to hot. Heating the rod from cold to hot. So the initial is cold, yeah. The final is hot. So when we want to find a change in temperature, we use the final minus initial. We use the hot minus cold. We use hot minus cold. Unlike the heat conduction, we use cold minus hot. For thermal expansion, we use hot minus cold. But it also depends. We use hot minus cold if we are heating up. If we are heating up the rod. But if we are lowering the temperature, we are cooling down the rod. Cooling down. If we are cooling down the rod it shrink because of cooling down. Then we also use cold minus hot. So it depends. For thermal expansion, it depends. Either is it we heating up the rod, or we cooling down the rod. If heating up the rod means it's from cold to hot. So initial is cold, final is hot. So when we final minus initial is hot minus cold. You cooling down the rod is cooling down. It means from hot become cold, cooling down. So the initial is hot, final is cold. So when we use final minus initial is cold minus hot. Okay. So thermal expansion can have two possibilities. Hot minus cold or cold minus hot, depend on the questions. All right. Now, we have linear expansion talking about length. We also have another two. We have also area expansion and also volume expansion. Okay. Yeah, this is the equation. Okay. We have change in length, length expansion. We have area expansion. We also have volume expansion. Okay, change in length, increase in length, or increase in area, or increase in volume. Yeah, normally for increase in length and increase in area, this thing only happen in the solid. Because only the solid, like metal rod, it has the length. For solid also, it has an area. for liquid and gas, it don't have a length. We don't measure the liquid or gas with length. We don't measure the liquid or gas with area. We only measure liquid and gas with volume. Understand that? So for volume, it has solid, liquid, and gas. So for solid, sometimes we use length, sometimes we use area, sometimes we use volume. But for liquid and gas, only volume. Okay, only volume. That means liquid and gas only undergo volume expansion. We don't use the length and area to measure liquid or gas. Okay, impossible to measure. Now, because we say liquid and gas only will occupy the container, isn't it? Will occupy the container. It's only the volume of liquid and gas matters. Yeah, only the volume matters. Now, now you see, change in length, the length expansion depends on three factors. Depends on alpha. What is alpha? Alpha is coefficient of linear expansion. Coefficient of linear expansion. What is actually coefficient of linear expansion? It is actually depend on the type of material. It's just like the thermal conductivity. It's just like the Young modulus. All these depend on the type of material. So now we are talking about thermal expansion. So we are talking about the ability of a material to expand. So coefficient of linear expansion depends on type of material. So different material, different alpha. Different material, different alpha. Like for example, I have steel and aluminium. They have different alpha. They have different ability to expand. So like for example, aluminium will expand faster when heated compared to steel. Steel expands slower compared to aluminium. So aluminium is expand faster. So for the one, if alpha is higher, means that material like aluminium will expand faster when heated. If low alpha, means that material expands slower when heated. Okay, so this alpha, beta, gamma, all these depend on the type of material. Different material will have different alpha or different beta or different gamma. Why we have beta, gamma? Why we have alpha, beta, gamma? Okay, beta is the coefficient for area expansion. If we are talking about area, we use beta. If we're talking about volume, we use gamma. Okay, so beta is the coefficient of area expansion. And how to get beta? If not provided in the questions, if the question only provide alpha, coefficient of linear expansion, but the question is about area, then we need to find beta. Yeah, how do we find beta if not provided beta? Only provide alpha. We can find beta by 2 alpha. Beta is 2 alpha. So that means if the question provide alpha, ask to find area, then we must find the beta. Beta is equal to 2 alpha. Yeah, 2 times alpha. But if the question about volume, but he give you only alpha, we also can find gamma. Gamma is 3 times alpha. Yeah, gamma is 3 times alpha. So this alpha, beta, gamma, it only depends on the type of material. Different material will have different alpha, beta, gamma. This alpha, beta, gamma talks about the ability of that material to expand. So the higher the alpha, or the higher the beta, or the higher the gamma, the higher of alpha, higher of beta, or higher the gamma, the material will expand faster. That means if the higher the not just alpha, the higher the beta also, the higher the gamma also, the material will expand faster when heated. Okay, if low alpha, low beta, low gamma, the material will expand slower when heated. So they depend on the type of material. And the unit is per Kelvin, and per degree Celsius. Oh, why have these two different units? Okay, I will talk about this unit later on. Okay, let us go back to the equations. Okay, change of length is okay. You see, the expansion of length depend on three factors. Expansion of length proportional to the alpha, proportional to the initial length, proportional to the change in temperature. That means the higher the alpha and also or higher initial length or higher the change in temperature, the more expansion. So what it means, let us look carefully here. Delta L is equal to alpha L naught delta T. That means the higher the alpha, that means I use something like aluminium. Something use aluminium with if I choose if I choose that means if I choose maybe aluminium. Okay, aluminium is expand very fast and very long, very long, very long initial length, very long initial length, and very big change of temperature. I mean, maybe I heated from 0 to 100 degrees Celsius. Very big change of temperature. So the more the expansion, that means I use a aluminium rod with very long initial length. Aluminium, and very long initial length. I heated from 0 up to 100 degrees Celsius. Very big change of temperature. Then it will have a lot of expansion. Understand? So these three factors, the higher the higher the alpha, the higher the initial length, the higher the change in temperature, the bigger the change in length. Okay? So they are proportional to these three factors. Okay? So same goes to the area and the volume. The difference is just the coefficient. Yeah? Alpha, beta, and gamma. Beta for area, gamma for volume. Of course, also if area, we use initial area. If volume, we use initial volume. Now, this change in length is alpha L naught delta T. Delta L also equal to final length minus initial length. So when these two equations combine, we can have this formula. The final length, when we combine these two formula, this formula and this formula we combine, we have this formula. We will get this formula. The final length is equal to initial length bracket 1 plus alpha delta T. Same goes to the area. Final area equal to A naught 1 plus beta delta T. Final volume equal to initial volume 1 plus gamma delta T. Now, delta T. Let's talk about delta T. Delta T is the change in temperature. Change in temperature. Just now I talked about what? I talked about the change in temperature. I heat from the rod from 20 to 100. That involve a change in temperature. Yeah, the length only expand when there is a difference in temperature. That means you must heat it up, then only can expand. If you don't heat it up to a higher temperature, it won't expand. Okay, you must heat it up to a different temperature, then only it will expand. Okay, so they involve a change in temperature, then only can expand. So this change in temperature, let's talk about the unit. Yeah, let's talk about the unit. This is change in temperature. Change in temperature is a final temperature minus initial temperature. And this one, final minus initial, not necessarily must be hot minus cold. It can have two possibilities. This change of temperature. It can be cold minus hot. Hot minus cold if heating up, or cold minus hot if cooling down. So depend on the situation. So it can have two possibilities. Now, I want to talk about the unit for change in temperature. So, change in temperature, either one. This one is the same as the thermal conduction, heat conduction, as I explained before. No matter you use degrees Celsius or Kelvin, for example, you heat it up from 0 to 1. 0 is actually 273. 1 is also 274 Kelvin. So when you minus the difference in temperature, you will get the same difference. This is difference of 1 degree Celsius. This is also difference of 1 Kelvin. So the change of temperature, no matter degree Celsius or Kelvin, is the same value. 1 degree Celsius equivalent to 1 Kelvin. So for change of temperature, we always use, we can use either one, degree Celsius or Kelvin. So if the question gives you degree Celsius, no need to change to Kelvin. If the question gives you Kelvin, you can also proceed with Kelvin. Yeah, you can use either one. So for change of temperature, remember, you can use either degree Celsius or Kelvin. But this is what we learned in this chapter, heat conduction and thermal expansion. These two, heat conduction and thermal expansion, only talks about change in temperature. Change, the delta, the change in temperature. This change of temperature can use both unit, yeah, either one, degree Celsius or Kelvin. If the question gives you degree Celsius, proceed with degree Celsius, no need to change to Kelvin. Give you Kelvin, you also can use Kelvin. But later on, further chapter, chapter 13 and chapter 14, we are going to learn about kinetic theory of gases and thermodynamics. These two chapter, you are not talking about change of temperature. You are talking about temperature at one point. Now we learn heat conduction and thermal expansion. These two, change of temperature, involve two temperature. You have initial and final temperature. Okay, because it involves two temperature, that's why you can use either unit, degree Celsius or Kelvin, because it involves two temperature. But for the kinetic theory of gases and the thermodynamic, they involve only one temperature point. For this one temperature point, like for example, the formula PV equal to nRT, this temperature, you need to change to Kelvin. You cannot use degree Celsius. You must change to Kelvin. And also the thermodynamic, this one involve the temperature at one point and change to another temperature. This one is talking about temperature at one point, temperature at another point. This one is not talking about change of temperature. Not change of temperature, it still stick with temperature at one point. This one also need to change to Kelvin. This is actually Charles' law. Yeah, Charles' law. This temperature, you also must change to Kelvin. You cannot use degree Celsius. Okay? When talk about change in temperature, then you can use degree Celsius or Kelvin. But if involve two temperature, you can use either one, degree Celsius or Kelvin. But if involve only one temperature point, you must change to Kelvin. Understand? Yeah. I hope you understand. Okay. And that's why now the unit for alpha, beta, gamma. What's the unit? Their unit is also per Kelvin or per degree Celsius. How to find their unit? Okay. Yeah, they can use either one because it's talking about change of temperature. Let's talk about equation for unit for alpha. To get alpha unit for alpha, we just rearrange this formula. Yeah, delta L equal to alpha L naught delta T, isn't it? We use this formula. We want to find the unit for alpha. What do we do? What do we do if we want to find a unit for alpha? The L naught and delta T, we throw to the other side. So it become, we use this formula, L naught and delta T, throw to the other side. So we got this formula. Yeah, L naught delta T go below delta L. So it becomes this formula. Alpha equal to delta L over L naught delta T. Actually, this is the definition of alpha. Okay. Yeah. So this is, do you see that? This one, this delta L and L naught here. This one go above. This one go above here. This delta L over L naught means the fractional change in length. The fractional change in length. And then below here we still have delta T. Delta T is the change in temperature. So what is actually definition of alpha? Definition of alpha is the fractional change in length when there is a change in temperature. That means if you increase 1 degree Celsius or 1 Kelvin, what happened? How much fractional change in length that happens? Understand that? The every change in temperature, how much is the fractional change in length? Or we can say, yeah, that's it lah. Yeah, that's the meaning of alpha. The fractional change in length per unit increase in the temperature. Okay, so now let's talk about the unit. Let's talk about the unit. Okay, so we have the delta L. Delta L is meter. Okay, delta L is meter. L naught is also meter. Okay, meter and meter cut off. And change in temperature can have 2 unit, degrees Celsius or Kelvin. Change in length, change in temperature can be degrees Celsius or Kelvin. So at the top, no unit. Yeah, meter divided by meter, because it's a fraction. It's no unit. Meter divided by meter, no unit per degrees Celsius or Kelvin. So that's why it ends up with either degrees Celsius or Kelvin. Okay, that's the unit for alpha per degree Celsius or per Kelvin. Okay, why can I have 2 units? Because the change in temperature can be in 2 units. Yeah, either one. So that's alpha. How about beta and gamma? Beta and gamma, do they have the same unit? Yes, they will have the same unit. You know, if you want to find beta, you just take the A naught delta T, go below delta A. The delta A over A naught is a fractional change in area. That also you get no unit. So finally end up with only change in temperature. So that's why you will get the same unit also per degree Celsius or per Kelvin. Okay, so for alpha, beta, gamma, these three have the same unit per Kelvin or per degree Celsius. Understand? Okay, so now and lastly, also we can compare between the different state of material, the gas, the liquid, the solid. As our general knowledge, we know that solid expands slowest. The gas expands fastest. Okay, we're talking about volume expansion. Yeah, volume expansion. So if we compare the coefficient of volume expansion, normally the gas has the biggest value of gamma. It has the highest value of gamma. Solid will have the lowest value of gamma. Liquid is in the middle. Okay, so the gamma for gas normally is higher compared to solid, or liquid is higher than solid, because the liquid expands faster than solid, the gas expands faster than liquid and solid. Okay, so the gamma, this one is the highest, the gamma for solid is the lowest. So the gamma means the ability of that material to expand when heated. Yeah, alpha means, or gamma or beta means the ability for that material to expand, yeah, when heated. Yeah, maybe I should say these three, they are ability of material, ability of material to expand when heated. That's the meaning of alpha, beta, gamma. Ability of material to expand when heated. Okay, so I think yeah, I think I've covered everything. Let me check. Okay, so important is this formula or this formula. Okay, you can get the change in length, change in area, change in volume. You can also find the final length, final area, final volume using this formula. The change in temperature is the final temperature minus initial temperature. You can use either degrees Celsius or Kelvin. This change in temperature can be either hot minus cold or cold minus hot, depend on situation. And what else? Yeah, let me see what else. Yeah, and sometimes the question will ask about density. Yeah, density is mass over volume. Mass over volume. So normally the mass is constant. Yeah, mass is constant. Mass is constant. What changes is the volume. Yeah, expansion, isn't it? So expansion of volume will cause the decrease in the density. So this also we will use sometimes in the questions. Okay, so yeah, that's all about thermal expansion. So now let's just look at problem solving. Yeah, I have several examples to show you. So please look at the videos for the several problems. Yeah, I hope you enjoy the videos. Bye.